Hello class, this is Mr. Parsons here. Just want to take a few minutes to talk to you about compound inequalities. Compound inequalities is two or more inequalities that are connected. It's either connected by and or by or. Alright, and so we're going to talk about that, what that looks like, and we're also going to look where instances where inequalities overlap. That's called an intersection. And we're going to look at a couple of those examples so we can be familiar with what our compound inequalities are. So let's go to take a look. We're using the word and basically when we use the word and, both inequalities have to be true in order for the whole statement to be true. So in this instance, I got x is less than -4. Greater than -4. Remember, it's an open circle on -4 going to the right. And then I got x is less than or equal to -3. Less than or equal to, that means all numbers less than 3, including 3, is part of the solution. So it's going to be a closed circle on 3 going to the left. So if we have x is greater than -4 and x is less than or equal to 3, another way that we can rewrite that is saying x is greater than -4 and less than or equal to 3. So you either see it with the word and, or you'll see it like this as a compound inequality. And so what that means is, if we was to graph this inequality, notice, look at what happens. Between -4 to 3, that's when our solutions is going to make the inequality true. And then I have an open circle to -4 going all the way to a closed circle with 3. All right. So any numbers that's going to be greater than -4 but less than or equal to 3 would be part of your solution. Alright, let's take a look at this. Now let's look at solving our compound inequalities. So I got 8 is less than or equal to h minus 2, which is less than 1. So what you want to do with your compound inequalities, separate them. Alright, let's ignore this part right here and just focus on a -8 is less than or equal to h minus 2. We solve our inequalities the same way we would solve our equation. Alright, we're going to do our inverse operation. You add 2 on both sides. -8 plus 2 gives you -6. So -6 is going to be less than or equal to h. After you do that part, now you ignore this and focus on h minus 2 is less than 1. And that's all for h. So add 2 on both sides, and so h is less than 3. So when you solve your inequality, all right, you're going to have -6 is less than or equal to h, and h is less than 3. So your compound inequality will be h is less than or equal to -6 and less than 3. Greater than or equal to -6 and less than 3. And so that's how it will look like. And then think about it graphically. Since it's less than or equal to, it's going to be a closed circle on -6. Since it's a less than here, it's going to be an open circle on 3. So I got a closed circle on -6 going all the way to an open circle on 3. So all of these numbers right here will be part of your solution set with your compound inequality. All right, let's do a check real quick. We want to go ahead and solve it. We want to solve for -7 is less than or equal to 3x plus 2, which is less than or equal to 5. So in order for us to solve this, all right, what we need to do, we got to break this apart. Ignore this part and focus on the -7 is less than or equal to 3x plus 2. Let's solve for that. And then after we do that, we want to ignore this part and solve for 3x plus 2 is less than or equal to 5. So let's go ahead and do this part first. All right, we want to go ahead and solve. So when we solve it, we want to go ahead and subtract 2 on both sides. So -7 minus 2 gives you -9. All right, and then we want to move 3 to the other side, so we're going to divide. So -9 divided by 3 gives you -3. So -3 is less than or equal to x. Now that we got that part, what we want to do now is ignore this and now focus on this part, and we'll solve for x. So subtract 2 on both sides. 5 minus 2 is 3. And then divide both sides by 3. 3 divided by 3 is 1, so x is less than or equal to 1. So our compound inequality will be x is greater than or equal to -3 and less than or equal to 1. If we was to graph this, notice both of these is less than or equal to, so we got closed circles. So we're going to have a number line with a closed circle on -3 going all the way to a closed circle on 1. And that's how you graph a look. Now let's take a look at the application. Cereal matter factors distributes cases of cereals to grocery stores. Each case contains 12 boxes of cereal. In order to pass the manufacturer quality assurance test, the case must be weighed between 336.4 ounces and 331.6 ounces, which includes 34 ounces for the weight of the case cardboard box. So that's our situation. What we want to do is write an inequality that represents that. So if let's go back to the problem. All right, we got 34 ounces for the weight because of the cardboard box. So the cardboard box is 34 ounces. So we got our number plus 34. It got to be less than 336.4, but greater than 331.6. So 12B, because that's how many boxes you have, plus 34, that's the weight of each box, is going to be greater than 331.6 and less than 336.4. Don't go ahead and solve this compound inequality. Ignore this part, solve this, and then ignore this part and solve that. So when we do that, we solve the left part. We subtract both sides by 34, and that's going to give you 297.6. Divide both sides by 12, 24.8. All right. Now we want to go to the other side, and we solve for this inequality. Subtract 36 on both sides. You get 302.4, and divide both sides by 12, 25.2. So our our box is going to be between 24.8 ounces and 25.2 ounces. So B is greater than 24.8 and less than 25.2. And if we was to graph this, we have open circles. So we got an open circle on 24.8 and then an open circle on 25.2. So get some more application here. Keyshawn has been saving to buy his first car. He wants the total cost of the car and fees to be more than $5,000, but at most $7,000. So think about that. The fees will be $700. So let's think about that. It's going to be $700. And so let's set this up. Our cost plus $700 has to be less than $5,000, but no more than. So greater than $5,000, but less than or equal to $7,000. So we're going to ignore this part. We're going to solve this part here. Subtract, excuse me. Subtract 700 on both sides. 5,000 minus 700. That's going to give you 4,300. All right. And then we subtract 700 on both sides here. 7,000 minus 700. It's going to give you 6,300. So our inequality will be x is greater than 4,300 and less than or equal to 6,300. So notice this is an open circle. This is a closed circle. So it will be an open circle on 4,300 going to a closed circle on 6,300. All right. Now, using the word or, this is called a union. So with the word or, it means either could work and will satisfy the inequality. So let's look at an example of or. So I have x is greater than or equal to 1. So that's a closed circle on 1 going to the right. And then I have x is less than or equal to -3. That's a closed circle on -3 going to the left. If I have the word or, x is greater than or equal to 1 or x is less than or equal to -3. Look how it looks graphically. It's a gap in your number line, whereas the and is connected together graphically. Or graphically, you're going to have a gap in your on your graph. And so what it tells me, either one of these can work and you will satisfy your inequality. As long as my number is greater than or equal to 1 or less than or equal to -3, it will satisfy the inequality. It doesn't have to be both. It can be one or the other. So if we look at this, we would solve this like we would a two-step inequality. All right, we just have to solve both inequalities. So if we solve this, all right, what we want to do, subtract 8 on both sides. That'll be 4n less than or equal to 8, and then 8 divided by 4 is 2. So n would be less than or equal to 2. For this one, subtract 7 on both sides. that gives you negative 3n is less than negative 18. And then if I divide both sides by 3, remember, anytime you multiply or divide by a negative number, your inequality symbol flips. So instead of it being less than, it's going to be greater than. So n would be greater than 6. All right. So this is how we look like when we would solve both. And so n would be less than or equal to 2, or n is greater than 6. And so graphically, less than or equal to 2, closed circle on 2 going to the left, n greater than 6, open circle on 6 going to the right. All right, let's take a look at this right here. It's saying select the solution for 5x plus 1 is less than 11, or negative 3x plus 10 is less than or equal to 11. We want to see which one will work with that. Let's do the 5x plus 1 is less than 11. Subtract 1 on both sides, that gives you 10. Divide both sides by 5, and x is less than 2. If we do this one, subtract 10 on both sides, that's going to give you negative 21. And then if I divide both sides by negative 3, since I'm divided by a negative number, remember the inequality symbol flips. All right, so I have x is greater than or equal to 7. So x is less than 2, or x is greater than or equal to 7. That's going to be A. All right, and if we was to graph this, all right, that's going to be a open circle on 2 going to the left, closed circle on 7 going to the right. All right. Overlapping intervals. So let's take a look. Solve these the same way we would with the OR, right? So what we do is subtract 12 on both sides. That gives you negative 10. So 4k is less than negative 10. And then you want to go ahead and divide both sides by 4. We divide both sides by 4. Then we got k is less than negative 10 fourths. Negative 10 fourths is negative 5 halves. So however you want to write that. And then for this one, we want to add 4 on both sides. That gives you 8. All right. And then 8 divided by negative 2. Since I'm divided by a negative number, my inequality symbol flips. So that's going to give me 4. So k would be less than 4. And so when we solve that, I mean not less than 4, k would be less than 0. You know what I'm thinking, because 4 minus 4 is 0. My apologies. So I got k is less than negative 2.5 or 2.5, all right, and k is less than 0. Notice they're going to overlap, all right, because if you graph this, you're going to have an open circle on 2.5 going to the left, but you're also going to have an open circle on 0 going to the left. So you want to choose one that's going to include both. And so if I choose one that includes both, my solution set would just be, the graph I would choose would be k is less than 0. Because look how I look. So if I choose the graph that have both, it will be this one. So k is less than 0. That's what you want to select. All right, select the solution set here. Let's take a look. Let's solve it. 4m plus 7 is greater than or equal to 19. Subtract 7 on both sides, you get 12. Divide 4 on both sides, you get m is greater than or equal to 3. And then let's look at this one. Negative 5m plus 5 is less than or equal to 0. Subtract 5. You got negative m is less than or equal to negative 5, but I got a negative m. I need to make it a positive. So I divide both sides by negative 1. And remember what happens? Inequality symbol flips. So it's going to be m is greater than 5, greater than or equal to 5. Think about it graphically. Closed circle on 3 going to the right. Closed circle on 5 going to the right. I need to select the graph that's going to include both. And so the first of all, the one I want to choose that will include both, that's going to be m is greater than or equal to 3, which will be A. All right. Graph the solution set. Hey, I'm going to have a closed circle on 3 going to the right. All right. And then just looking at your graph, notice what happened. I got an open circle on negative 2, closed circle on 4. So x is greater than negative 2, but less than or equal to 4. All right, which one to describe the graph? An open circle on 7, closed circle on 9. Hey, x is greater than 7, but less than or equal to 9, and the answer is going to be D. So I hope this helps with our understanding of compound inequalities.